All right, for chapter 15, my group is B, and I'm person 2. My UVU ends in 8, and I'm person 2. So my acid and base concentration, I figured the formula, and then to figure out the initial, we're going to take the pKa and take the 10 base exponent to get this number. And then we have to set up an ice table based off of the initial acid concentration. So then we do the setup of products over the reactants, and then we can solve for that, and assuming that is negative or less than 5%, we calculate that, and then we can divide it by that to figure out that it is. And to take the negative log of this number of x gives us the pH of 2.71. And we also know that volume is moles per molarity. So we're going to take the liters multiplied by the molarity to get the moles, and that gives us that number. And then to figure out the volume of that, we can divide the moles from the molarity of the base, I believe. Yeah, the base. And then, so our equilibrium volume base is going to be the 9.857. And then we're going to try and figure out a third of that. So then 9.86 divided by 3 gives us that many liters, and we're going to times it by the base constant to get that many moles. Subtract it from the remaining acid to figure out, okay, we have this many moles of the acid. And then we're going to do the Henderson formula because we know the pKa value, and we know now the base and the acid, the moles of each. So we can calculate that out and get 4.52. Then for the same thing, we know 2/3, so we're going to figure the base constant times the liters is this many moles. Subtract it from the initial value to get that number. Plug it into the formula to get 5.12 of the pH. And then this is nearing the equilibrium, but it's not quite, so we have to do this step again. Multiply by the molarity by the 9 point whatever milliliters to get this many liters, that many moles. So we subtract them to figure out how much excess, and then we can use the Henderson formula again to give us our new pH. And then at equilibrium, we know the volume is 9.86, all acid converted to the conjugate base. The solution is basic, so now we know that we can calculate the moles of HA in our equation by multiplying by the acid initial value, molarity, multiplied by the liters to get that many moles. And then so we have to convert the volume by dividing the moles from the molarity, and we get 9.86 milliliters, or we know that. Yeah, so that's the calculation of that, but we need the SB value, so we can do the 1.0 times 10 to the negative 14 over the Ka value, and we know the, we can divide those two to get the Kb. Sorry, one second. But yeah, the A value then is that base value divided by the total liters that we just calculated by adding the liters calculated from here plus the initial 0.025 liters, and that's what we get for the molarity. Then we can use an ice table here, so we know that the initial value that we calculated over here was 0.1815, and then we can use the ice table to figure out the formula, multiply each side, take the square root, And then we can check to see if it's less than 5% because we can divide that by the initial value, and it's like 0.006%. Take the negative log of that, add it to 14. Well, I add it on my calculator because it's hard to do the negative log, so I just do the negative plus 14 to get the pH. And then the 101, we're going to do the same thing, times it by the initial volume to get 9.96. And then we're trying to figure out the moles of the KOH, so we multiply the initial by the volume to get this many moles, figure out the excess, and then we figure that that's the excess here. Yeah, so those two minuses that, and then we plug it into our equation. So we do the excess moles over the total volume, so we have to add both the volumes to get that molarity, plug that into the equation, and we get 11.26. Then we're going to repeat the same steps again. So 4 times 9.86 divided by 3 is 13.15 milliliters. We're going to plug that into the initial values to get the moles, subtract it to get the excess amount of OH, and then plug it into our equation of the total volume to get that many moles, take the negative log, 12.74. And for H, we're going to do the same thing, 5 times 9.86 divided by 3 gives us that many milliliters. Convert that to liters. We do the initial value times that liters equals that many moles. And then we're going to do the same thing, so we're going to subtract it from the initial value. So now we know that this one is an excess, so that we have excess KOH. And then the volume is that initial liters plus the milliliters calculated here. So it's 0.0414. We divide those two to get the molarity, and we plug it into the formula and get 13.01. And then on that rack I just put them all together so it could see as we increase the volume of the base, the pH is also increasing. And yeah.